Everyone, and welcome to LunchBytes. LunchBytes is a fortnightly live stream where we focus on the best of the UK Microsoft technical offerings. And so we get people to come and talk about their passions, their interests, everything related to Azure. It's brilliant to have you. And as it's a live stream, there's a couple of things that we ask everyone to be aware of. And that's that you're aware of others by being welcoming and respectful, being understanding of people's differences, being friendly and patient, be open to all questions and viewpoints, and be kind and considerate to others. My name is Ty Brennan. I'm an application innovation specialist, so I focus on all things kind of developer related within Azure. And I'm joined by Jose.
Hi, everyone. Thank you, Ty. I'm Jose Alonso. I'm a cloud solutions architect here at Microsoft, as well in app innovation. Somewhat similar to Ty, I work with our customers and guide them and advise them on the technical aspects, anything around app development.
Brilliant to have you on board today, Jose. And in today's episode, we're going to be joined by Owain and Steph. So I've just brought you both up on screen. Brilliant to have you on LunchBytes, but both of you have actually been on LunchBytes before. So I'm still going to ask for an introduction, but yeah, it's brilliant to see you coming back on again. Owain, do you want to introduce yourself?
Yeah, certainly. Thank you, Ty. So my name is Owain Osborne-Walsh. I'm a cloud solution architect at Microsoft, primarily in our app platform space. So same area, app innovation, all things containers and Kubernetes.
Brilliant. Steph?
Hi, folks. Lovely to be on again. My role at Microsoft is helping businesses work out the right technical solution to solve their business problems. So we get to have fun every day solving big challenges and helping make a difference.
Brilliant. Great to have you both on. And so as it's a live stream, in terms of everyone watching live, you have the opportunity to ask questions, and we will have a Q&A section at the end of the session as well in about 45 minutes. So please do chuck your questions into the live chat. And there is, for accessibility, there's captions available on demand as well. So Steph, I'm going to hand over to you and share your screen, and please take us away.
Awesome. I'm actually, Owen's going to kick us off. So Owen?
Yeah, thank you, Steph. So yeah, welcome everyone. Today we're going to be talking about Azure Static Web Apps. And more specifically, we're going to be talking about a thing that we like to call serverless magic within Azure Static Web Apps. So to start with, we're going to take a look at the kind of fundamentals of serverless computing and what that means at Microsoft. We're then going to be able to jump into a kind of look specifically at what makes our static web apps so particularly magical now. And then finally, we'll have a quick look at a demo and how you guys can get hands-on with Azure Static Web Apps. So to start with, if we look at the evolution of computing, we can see that we've essentially moved from the kind of physical server all the way to virtual machines. That's kind of the first jump that we saw in terms of the computing evolution. I'm just checking on my side. It looks like the slide hasn't moved. Is that the case quickly?
I'm experiencing some technical difficulties. I have a cute little egg timer saying, no, Steph, you clicked too many things at once.
Oh, no.
Yeah, looks like just the slide's frozen. 1 second.
No. I'm going to do the classic turn things off and on again. Bear with me.
In the meantime, I don't suppose there's any questions already, are there, Type?
Unfortunately, none have come through yet, Owen.
That's fair enough. Well, I'm happy to expand on the subject quickly in the meantime. So yeah, primarily today we'll be looking at static web apps. Static web apps is part of our kind of PaaS offering. So that's our platform as a service offering at Azure. And primarily we'll be looking today at how we can use static web apps to kind of eliminate some of the, unnecessary cost in our architectures, where static web apps can come in and play a role within some example architectures. So we look at, doing things like pre-rendering certain web pages using static web apps in combination with app service and some solutions that people are more familiar with. And then finally, as I mentioned, there's also a chance at the end of the session today to get kind of hands-on. There's a workshop that we ran that kind of was the inception of this serverless magic content that we ran in Cardiff originally a few months ago last year, and was really well received. So there's a chance and some links at the end for people to kind of build out a lot of the stuff that we'll talk about today and get hands-on.
Yeah. So static web apps has been around for, I guess, a little while now, short time in comparison to app service. I guess, can you talk us through a little bit about kind of the context, the reason why it came into existence, and maybe a bit of a comparison in comparison to stuff like app service?
Yeah, so we're talking about a difference in terms of where we're rendering and building our kind of website content. I think the important thing that static web apps provides is a hosted and managed platform for specifically, like we kind of said, web applications that can be kind of pre-rendered and can make the most of other parts of kind of Azure services for the integration side of things. So if we think about APIM, if we think about Azure functions, integrating that, creating a platform that integrates that, it is really important to kind of leverage some of the true power of static web apps and expand the use cases. Because originally, we have services like blob storage, or on AWS, they have S3 where you could upload your kind of HTML files and host them, statically there, again, at very low cost. But when you got past anything that was kind of just a basic kind of use case, maybe just for like a blog that you're occasionally updating or something like that, those kind of pieces around integration, calling APIs and using databases and those kind of things became more complicated. So static web apps as a PaaS offering makes that a whole lot easier, and hopefully we'll kind of walk through today what how we're able to do that with some of the kind of add-ons within the PaaS service.
Yeah, and so there's multiple ways that you can host kind of these web apps as well. Like you mentioned, static web apps has come in more recently. You've got app service as well, and people can always containerize their applications as well. It doesn't really matter if it's kind of where it's sort of rendered for containerization. What's, I guess, the comparison story there?
Yeah, certainly. So I think when we look at the difference, I think that it can be slightly sometimes overkill to have to create and manage an entire platform just to host maybe one or two applications, especially when we start talking about applications that are static and don't require a massive amount of compute. And in general, when we look at PaaS offerings, and that could be for containers, that could be AKS, that could be Azure Container Apps. They are built and build based on the amount of compute you're using. Oftentimes, when you start looking at kind of enterprise features, you're also looking at having to commit to having certain types of SKUs and moving away from consumption. So you start looking at having to use or commit to X amount of vCPUs and X amount of RAM per node or per environment in ACA. And with static web apps, it abstracts a lot of that. You don't have to worry about the kind of compute that your website is using in the back end. All of that is abstracted when you're deploying. And that means that, fundamentally, you don't have to worry about the underlying platform. All of that is managed for you. And any complexities that people, especially when we look at kind of more solo developers or smaller teams may feel around having to manage things like Docker files or manifests or services to be able to kind of route traffic, all of that is handled for you, which makes static web apps a really easy way of getting up and running for web applications that are suitable for the platform.
Yeah, brilliant. So we're just having a couple of technical issues with Steph on the line at the moment. The internet is down at the moment. And I was thinking, on your end, potentially, is there something we can do around showing the slides from yourself, and we can look to potentially run through?
Yeah, let me have a quick look.
Yeah, no problem.
Let me see if I can quickly export these slides as a PDF, and we can see if we can get them uploaded that way.
Yeah.
believe the slides will be uploaded. Now these won't have this won't have the video for the demo in it, obviously, but it may allow us to share the screen in the meantime.
Yeah, here we go.
Okay, perfect. Right, I'll kick us off. Hopefully Steph gets the opportunity to rejoin us. And yeah, potentially at the end, maybe we'll switch the source and run the screen share from Steph's, run the demo from Steph's screen share if we get the chance. So yeah, just to touch in, we have kind of delved into a little bit of detail so far anyway on the evolution of computing when we've spoken within this introductory bit. But as I was mentioning earlier, we have this idea of we've moved from this idea of the physical server, which obviously, even when we talk about serverless, the physical server still exists at the back of it all. But we've obviously slowly abstracted away, and we can see that kind of level of abstraction getting higher and higher as we move through this kind of evolution of computing, and going from physical servers to virtual machines to platforms as a service, into then containerization, and finally towards this serverless approach, where again, we're still having to, that doesn't mean that, completely everything under the hood is scaling up and down to zero. That can also mean that you're not having to worry about the underlying infrastructure when we think about all of the types of considerations when managing a physical server, like, managing the hardware, when we think about virtual machines, patching the operating system, when we think about, any kind of networking requirements, that kind of thing, we can start to abstract and move away from with serverless compute. So Azure Serverless, has many different facets. It's not just one single platform. It's a kind of group of multiple services that make up this idea of our kind of total serverless offering. And you can see at the top here, we have static web apps. So today we're going to be talking about static web apps primarily, but it's not the only serverless offering or serverless service that we have. We also have API management. We have functions, we have logic apps, and we have event grid. And the way that we're looking at these is, a lot of when people start talking about serverless, I feel like the thing that people are most immediately familiar with is either Azure Functions or AWS Lambda, because of the kind of functions as a code and how excited people were initially when they launched at being able to scale down to zero, execute specific snippets of code, and that be essentially as far as you had to think in regards to the management of the underlying compute. But we're starting to see that expand kind of further and further into these other services like event grid, like logic apps, like APIM, and building that platform on top. And this then feeds directly into challenges. So whenever we're looking at these services, we're also then thinking, right, how are these mapping to customer challenges? And some of the most common customer challenges that we kind of speak about with our users or with our customers is, user experience. So obviously enterprises are concerned about how do we provide our customers the best possible user experience to increase return business, to increase things like conversion rates. Certainly when we think about it from an e-commerce side, to not lose that business to the competition. At the bottom, it mentions here kind of site performance is one of the key things that we can do here. And I'm sure everyone's experienced it themselves on this call or, within this stream, that they have been to a website that has had, terrible performance for one reason or another. And that has driven them to go and get whether that is that information or that product somewhere else. The other concern from enterprises past, the kind of commercial concerns are, from the perspective of my workforce, how can I enable developers to be more productive and to work more effectively? And there's a whole host of things that Microsoft are doing in this space. But again, the key thing here comes back down to developer tooling. So the IDE, the pipelines that are in place, the tools that exist within the developer workstation, all of these things tie straight back into productivity. Then we think about the workflow. So, that classic, it works on my computer, but it won't run in production, or it's failed all of the testing when we pushed it through our testing cycles. So how can businesses ensure that kind of workflow from local development to production is as smooth and seamless as possible, with all the right checks and balances in place to make sure that we're pushing quality code, through that workflow. And then finally, scale. Scale is not new anymore. The concept of auto scaling, the concept of benefiting from cloud scale, is something that has really driven that push and have driven a lot of customers initially to the cloud. But it still becomes a question when we drill down past the scale that's available. It's how do I scale effectively? How do I scale in a cost effective way? And how do I ensure that I'm scaling for the traffic that I want and not necessarily for malicious traffic or traffic that's moving, that's coming from sources maybe that I don't want to serve traffic to. So these are some of the kind of challenges that we see businesses facing and that we kind of talk to customers about on a day-to-day basis. And a lot of these can be answered for certain applications by Azure Static Web Apps. So we spoke about it, during the kind of start of this call. Azure Static Web Apps is a platform as a service offering from Azure that provides some kind of key capabilities. So things that we're looking at here, so global hosting. So let's tie each one of these back to one of the challenges from the previous slide. When we think about performance and think about latency, think about, scaling back those load times, that's immediately where Azure Static Web Apps, by using a CDN, by using global hosting, can provide that, incredible kind of milliseconds of performance to customers to avoid some of the potential problems that you face when that performance isn't there. We also think about the end-to-end development experience. So having clear tooling, integration with GitHub or Azure DevOps, being able to build and debug locally and push that workflow through to the cloud. And that ties in again with streamlined build and development. So Azure Static Web Apps looks at having a workflow and integration with your GitHub Actions and with your other pipelines to be able to have that kind of, as I mentioned, that quality control in place still with familiar tooling to make that end-to-end local development to production workflow as seamless and as smooth as possible, while still ensuring that those quality gates are in place. And then finally, when we think about scaling, Azure Static Web Apps is fully managed, but also cost effective. So it's, as I mentioned, one of our serverless solutions. And what this means is you don't have to worry under the hood about, the upgrading and patching of your static web apps, and more specifically the hardware that they are running on, because we take care of that for you, and you can scale, depending on the amount of traffic coming to that particular web app. So in terms of key capabilities, drilling a little bit further down, when we talk about global hosting, we're talking here primarily about, as I mentioned, kind of content delivery networks, globally distributed hosting with, different edge locations across the world. And as a result, those static web apps being delivered from a location as close to the user requesting it as possible. When we think about the end-to-end development experience, one of the things that we like to talk about is empowering our customers, developers, to be able to develop in their preferred languages. So no lock-in or requirements in terms of the kind of specific framework or language, or having to learn a new framework or language to use Azure Static Web Apps. Developers are able to use the languages and frameworks that they're already working with their static web apps to, again, tying that back to productivity, remain productive and use the tooling that they're familiar with. When we think about, drilling a bit deeper into streamlined build and deployment, as I mentioned, having native GitHub workflows for CI/CD, so being able to have that integration through the portal for your existing, using your existing DevOps practices. And also, one of the things that we'll take a look at in the demo is the different environments and staging environments that we have supported out of the box with static web apps to allow, full validation for any changes that are being pushed through in a safe production replica test environment. And then finally, as we mentioned, the kind of cost-effective nature. So always on traffic monitoring, being able to build in authentication, being able to integrate with Azure Active Directory, all of these things that are done, as part of that managed service that again we'll jump into and take a look at when we get into the demo, and you guys can take a look at in the workshop after the session. But with that, I will now move into Azure Static Web Apps and some of the more practical examples of their architectures, and how we can leverage some other services in combination with Azure Static Web Apps in some real-world examples. So one of the examples here is a retail application. And I'm conscious of the fact that we've obviously had a bit of time at the start here, so I'll go through these a little bit kind of quicker. But here, the main thing to call out is obviously you can see kind of some of the tooling, and you can see the general flow. So we have Azure Static Web Apps leveraging Azure Functions. So that ties into what myself and Ty were talking about at the start of the session around the benefits of using Azure Static Web Apps as a PaaS service and having that integration built into the platform. And still being able to obviously dynamically serve and display data coming from, potentially blob storage, Redis cache, or an SQL database. But the other thing to call out here is this kind of pre-render of the static site, and using that in conjunction with something like App Service to be able to render certain parts of your website, in advance, and again increase that performance. And lower the latency for the customer. Then when we look at it as kind of more of a serverless app, we have this example here of having static website hosting and using a combination again of some of our PaaS services such as Cosmos and APIM and a function app to be able to go away and handle something like authentication, as we can see there with Azure Active Directory or Azure Entra. But also the key thing to call out on this slide is using, like we were mentioning about developer productivity, the CI/CD tooling such as Azure Pipelines or GitHub Actions, Azure Monitoring, all of these types of services. We're able to use that shared tooling across both Azure Static Web Apps and our other PaaS services. So it really accelerates that kind of developer velocity when we think about developers starting to build using Azure Static Web Apps. And then finally, we have this example of Azure Digital Twins Builder. So Digital Twins is one of our IoT services. And again, the main thing to call out here is using static web apps, essentially as that front end, and leveraging Azure Functions, or maybe possibly in a combination with APIM. We'll look later at how we can leverage Azure Functions, without APIM as well, to dynamically serve that content and still dynamically display content from our databases, from our different backends, such as digital twins. So ingesting IoT information and doing that at a large scale. I'll now pass over to Steph, who I believe is back in the game to talk us through Azure Functions.
Fingers crossed. I went through a fun, hard reset, so we'll see how it goes. So inside our use cases, we mentioned Azure Functions, and these become really integral to building distributed applications that you where you can more easily pay as you go for the consumption that's happening. So you can scale costs predictably and have different models to support different types of use cases. But the idea between Azure Functions is to take a code-first approach where you write as little code as possible to get the job done. So the integrated programming model, and we'll see that in a little bit more detail, has easy connections to things that happen in our environment, like a new message arriving from a queue, or from a new change in our database, to being able to grab data from different locations, be able to do something with it, and then be able to output the results easily. And the great thing about this is it means you have to spend the code that you write is more focused on your business logic. So this is my preferred way of writing code, because I love code first, but I want to write less of it. And you only need to worry about your runtime, and you don't have to worry about anything else. So it's very flexible, and you're able to host it in Azure, but you can also containerize it and run it in different places as well. So you can run this on premises as part of a pure on premises or even hybrid solution. As I said, the integrated programming model helps us trim down what we write. So there is usually a trigger, as I mentioned. This could be an event, but it can also be just a HTTP call. So we're able to use Azure functions to make APIs that respond to get, post, put, and patch, and those kind of things, to enable us to be able to provide a full programmatic interface. We then have our inputs, and those generally focus on our Azure data storage solutions. But you can also bring your own data inputs inside your code. And then you have your outputs. Again, these are things like queues, databases, files. And this enables us to be able to really build connections between our different code solutions and different software. And this is where, for the Azure Static Web Apps, we need our APIs to be able to connect into our data stores and things like that. Functions is a great way to achieve it. It is also a great way to call things like Azure OpenAI, but be able to put the safety guardrails around it to do things like check and see if you can access something from a cache to be able to return a response instead of, and be able to add some controls around it instead of going direct to your OpenAI API. Azure Functions allows us to write as minimal code as we can to be able to connect to things. But Azure Static Web Apps actually is able to take it a little bit further with this cool open source project called Data API Builder. I said functions enables you to do your get, put, patch, delete type things. Well, the Data API Builder programmatically builds those for you instead of you having to do it. So this is perfect for the operational database that will be your primary data source inside your static web app. So you have your data source, you put, you're able to use some configuration, and when you deploy to your static web app, it will in memory create your REST and GraphQL endpoints and be able to give you the Swagger documents or the GraphQL introspection easily so that your app can use them. And you can also, with integrated authentication, be able to use them from other applications as well. It's fully open source, which is fantastic because it means we can increase the speed of development. You can take the Data API Builder, run it in a container or run it locally, and be able to put it against many of the common databases. So it's by current levels, you can run it against any against SQL Server variants, Postgres variants, MySQL variants, and Cosmos DB with the core NoSQL relationship. So this enables us to take a state-based model. So you design your data model and you design your application and you connect the two instead of having to write all of that middleware. It's really easy to get started. So we have a configuration file. This enables us to put things like cause policies in. We can put our entities in that we want to map, which is great because you don't want to expose all of your database by default. You want to be able to bring things in that you prioritize. And you're also able to really quickly configure your role-based access controls, which means much less pesky writing about those things, and it picks up off the authentication claims. So you're able to take the user ID and basically build that where clause really quickly, and it gets automatically appended to every query to be able to ensure that your API cannot be broken to be able to Bobby tables or or be able to see other people's data. Azure Static Web Apps has what we call the easy auth system, with where you're able to basically turn on authentication for Azure Active Entra B2C. You can bring in then social logins like GitHub OAuth, Gmail providers, and so on. And with that, you're able to pick up those tokens, those JWT tokens, and be able to use claims and information to be able to use that information inside your application generally, but also be able to use that for that role-based access controls. So it's incredibly handy. So to get started with static web apps and be able to kind of bring your database, you can start with your usual workflow for a project. So if you do npm and create a boilerplate app and run with it, that's how you can start. There's a template, vanilla boilerplate template that you can do. I'm also a really big fan of GitHub Copilot's create workspace command with the Copilot chat. And that enables me to give lots of requirements to say, like, I want a Vue.js static web app that is for manufacturers and has, this logo and these things in its nav bar and a user profile section. And the create workspace will kind of try and work out what files are needed and what code should be in there to be able to get that going. So lazy me, I love that AI to help write things. Once you have your single page application, you can then use the command line interface for static web apps, SWA, to be able to initialize the project as SWA compatible. And it will look at your packages.json and things like that to be able to work out what frameworks you're using, what your kind of your build commands and your local dev pieces are, and add those pieces to a configuration file that allow us to be able to do local development and be able to tell our production environment then where the URLs are going to, like, what are the relative URLs for some of the APIs. To be able to use the kind of automagic middleware, the data API builder, there is preview support for this inside static web apps. So we would do SWA, DB, and init, and you say what type of database it is, and you can put your connection string in, although you have like .env type support. And I would highly recommend you do not embed your connection strings inside that configuration file, but use environment variables instead. But you can also do this with the DAB command line as well. Once you've got that connected to your database, you can then configure your strings, your REST and GraphQL APIs. You can say where they're going to, what endpoints they're going to be available at. You're able to set the CORS policies, the how it's going to be authenticated, and then you can implement your entities to start bringing parts of your database in to be able to get those CRUD, create, read, update, delete APIs being built for you. And then you run it. So instead of like an npm dev type command, you instead do SWA start. We have some extra information we can provide it. So if you're not currently in the directory where your static web app is, we can configure those. And we also can then add additional functions. So I mentioned earlier that as well as being able to connect to our database really easily with the data API builder kind of automagic pieces, there's always going to be bits like the OpenAI or a third-party API or something else in your environment that you need to talk to. We're able to bring any existing APIs to be able to more easily query them, but we can also have a really light, easy way to create a managed functions environment. So you don't need to do all the bicep pieces to create the function space. When you have an API area that uses Azure Functions, it'll create and look after that for you. So you can be writing your Blazor or your JavaScript app, and then also have those functions that leverage all of that minimal code capability to be able to go and talk to other parts of your environment. So you get the automagic to talk to your database really easily, and then you use the managed functions to write minimal code to connect to other parts of your estate. And then you deploy. So when you go into the Azure environment or you use Bicep to do this, you can create your static web app. If you use the portal, especially for the first time, you can connect it to your repository, and it will put the CI/CD pipeline created for you by default. So you don't even have to write that. And then every time you do your commit push, like by default to your main directory, you'll get a new version of your app deploying. You can deploy from a command line, which is, or from VS Code, which is brilliant for that kind of like ad hoc prototypey stuff. But that longer term CI/CD is definitely what I'd recommend. So I think now, Owain, you're going to show us, you know, the setup is quite easy, well trod, but what does it look like when you've published your application and you now need to do some more stuff to it? So what does the day-to-day dev experience look like? You're on mute.
Classic. I was just saying, if Ty could do a bit of magic, and if he'd be kind enough to try and bring up my screen share, and we'll give the screen sharing a go again, and I should be able to walk you guys through the demo quickly. So you can kind of see at the start of this, as I mentioned, this is something that you guys can get hands-on with. The next slide after this is the link, and this is built from a workshop that we ran in Cardiff as part of the kind of serverless days event that happened there. Essentially showing off the value of the static web applications and the data API builder. So what we can see here is that we've essentially at the start created and connected a database that is our kind of to-dos, our SQL database that has our to-do list within the database. And we can see here that we have this static web application. We can see, it's a Vue.js application. We're able to add items. And when we're doing that, we're using the existing API that has been created through the data API builder to add that add that to do to the back end. Now, what we can see here is that we have these deployment scripts. And the main purpose of this is that what we want to do is create a new part of our to-do application that shows in progress to do. So we have the ability to add a to-do item, we have the ability to delete one, or mark one as complete. But let's say that we're working on one that's a little bit longer term. Can we add an in progress option? So you could see before I paused in the last file, we could see that we had added some information about essentially the kind of API that we wanted to call. And now we can start to see that within this deployment script for our SQL database, we've added this in progress field. And then we see this static web apps database.config.json file. And this is the configuration file that Steph was talking about earlier, where we're able to start to be a little bit more granular and specify within our for data API builder what we want to expose, what endpoints we want to expose. Do we want to expose REST, GraphQL, the authentication that's required, and the different entities and permissions required. So we can just see that as an example, and we can kind of see just how this is essentially generated. You can see the kind of rough idea, and this happens. This occurs when we, essentially start to use the data API builder itself. But we don't need to make any changes to it. We don't have to declare here that we want to add a new API. This will all be built for us based on the some of the points here. So we're not specifying anything that we don't want to expose in this example, but primarily based on the data in the connected database. Oh, that seems to have taken us all the way back there. So yeah, if we go to if we go and make our push, we can see here that we're adding an in progress feature. And the main thing to call out here is that we're pushing this to a development branch of our repository, and we'll see why that's interesting in a second. But you can see here that we're building and deploying the new database, the database containing our in progress feature. Obviously, we added that kind of small line of code within the actual Vue.js itself. And interestingly, here's something to call out. This is within our build step of our build and deploy pipeline. So when we're talking about developer productivity and end-to-end workflows, this is our GitHub action that is deploying the actual static web app itself. And we can see here within this Azure Static Web Apps deploy task that we can specify specifically the data API location. So just something to bear in mind. That can be obviously changed based on the location for your connections. And what we can see here is when that's done, we have this preview deployment, and this ties into one of the benefits of static web apps that I was talking about earlier when I was saying about the different production replica deployment environments that we have that we can use to do full end-to-end testing of our changes. And we can see here that, again, another feature to call out when myself and Tiger were discussing at the start of the session the benefit of using static web apps over some of the traditional hosting options for just chucking your HTML files into blob storage. We can see here that we also have this feature which allows us to specifically for different environments reference different databases, but also bear in mind how easy it is for us to reference this database. We're able to go into our existing databases within our subscription and just connect them without having to manage any of the strings within our application or passing them through as separate environment variables at build time. We're able to essentially do all of this as part of through the portal as part of our Azure integrations. And we can see here that we're just adding the password. And we can then see that that connection has been created. And what that means is we now have these two different environments. And again, we can do things like traffic splitting. We can do things like individually browsing preview environments while keeping our production environment up and running while we make these changes. And when we then go to browse, we can see that we have this nice timer. I mean, you can see that this is truly the extent of my web application development skills. That was probably the biggest challenge for me on this one. But as I called out, and if Tiger would be so gracious as to bring these slides back to the forefront, you know, one of the things that we can do, as Steph will now walk you through, is look at getting you guys hands-on with this exact demo.
Awesome. Thank you. So, yeah, as Owain said at the beginning, we first started teaching this with a Serverless Days event in Cardiff in the UK, and we built a great workshop to take you through deploying your first Azure Static Web App, being able to make changes to it, and then even giving you some bonus challenges depending on your kind of preferred focus, to be able to do some of the infrastructure as code, or be able to add additional third-party functions, or be able to connect to the data for it. So you can get hands-on with this link, and we'll share that into the chat when we can as well. But you can go and look at Cardiff Serverless Days workshop in GitHub if you're incredibly keen right now. And what you'll be able to do with that, as I said, is you'll be able to deploy a working to-do application. You'll be able to see the SQL data, how you work with a relational database, which is a great question in the audience of being able to, you know, how does this plug and play with your database? Relational pieces, you'll take a step-by-step through making a change, see how you deploy it with CI/CD, and then be able to extend and continue using that continuous integration and deployment capability. As well as getting hands-on, you probably also want to be able to read up a bit more about the different functionality, because obviously we only gave you a very quick teaser of some of these pieces. So when you're looking at the documentation, you want to look for the Azure Data API Builder, Azure Static Web Apps, and more generally look at Azure Serverless to see how you can more quickly build highly scalable, cost-efficient applications that mean minimal patching, dependency management, and like, I never want to have to write an ingress pod, an ingress container piece. So yeah, just being able to get like all the custom DNS and things is much easier for me inside the Azure Serverless environment. So that's it from us. Tig, I think you've got some wrap up and some questions.
Yeah, absolutely. Thanks for running through that session. Jose, I'll get one of that first questions uploaded now. Yeah, take us away.
Yeah, absolutely. So, well, I think you've already covered quite a few points, right? Especially in the beginning when we had that conversation. But I feel like now, after going through it, after helping our audience really understand the key topics, I wanted to maybe ask again, in case you want to go a bit deeper in the topic or add something else, as in, why should I use this maybe instead of containers? And you've mentioned already all the simplicity to it, but is there anything else that you'd like to add to this?
Yeah, so I'm happy to take this one. I think that past some of the points that me and Ty discussed, and that simplicity and ease of use and integration, like we've seen with this, is you know, plenty of brilliant reasons as to why, you know, for kind of static web apps in particular, you want to use a dedicated service. One of the other main things is cost. Kind of as we mentioned, you know, the ability to scale. your static web app and leverage, for a really low cost, leverage things like CDN out of the box, and all of those kind of things, and not have to consider that as you would with other containerized platforms.
Yeah, absolutely. Yeah.
And on the point about the databases, so having a data and AI background, I love it when developers think about their data model and things like Cosmos DB. If you don't get the data model right, you pay tons extra. And just generally, if you don't get your data model right, you pay for it in performance pains. So the thing that I love about the static web apps with the relational databases is you can easily create a mono repo that has your database code. So I rely heavily on database projects or Azure SQL databases, and I'm able to specify my database structure and be able to then specify up my app code, my front-end code, and then have a single CI/CD that will deploy idempotently a state-based change to my database. So it'll ship the extra columns and things like that. It'll then go through, and as it deploys the static web app, regenerate all that middleware tier of the create, read, update, and delete APIs, and just make it very easy for the application developer to think, what are my fields that I need related to my entities, minimally specify them with SQL, and then just focus on the front end. So it's brilliant for full stack engineers or teams collaborating in one place.
Yeah, that's incredible, especially for developer productivity, as you said. Yes. We have another question. How can you securely manage different environment variables and integrate with Key Vault, for instance?
Yeah. So in our demo for the hands-on lab, we show how you can manage your different environments database connections through the browser. That is a nice, easy prototyping way of doing things, but it's not a good long-term safe way of doing things. Azure Static Web Apps can contain environment variable files. So you can do like your local .env type solutions or your kind of app config, if you're doing Blazor. Azure Static Web Apps has an app setting space, just like Azure App Services. And so you can create per environment the different environment variables that you might need, like your database connection strings. And because it uses the same kind of functionality as app services, you can do @Key Vault type things to be able to go and route to your secure store of your connection strings. With a managed identity, your application can be authorized to talk to Key Vault in certain ways, and that enables you to bring those connection strings on demand in the most in a really secure way.
Yeah, absolutely. Really good detailed answer. Really on top of things in terms of security, right? If you want more details about it, we've just shared in the chat a link to Microsoft Learn document where you can read more about this and find the details that you might need to get this rolling. And we've also shared the link directly to the repository that Owain was talking about in case you want to go ahead and get hands-on with this, see what you can learn, what you can achieve. Really good materials. And I think we don't have any more questions at the moment. Is there anything that any of you want to add before we close?
Just that I think in a couple of weeks, I'm going to be with you to talk about how data folks and devs can do more impactful operational and analytical data environments, and be able to add things like unit testing, co-coverage, CI/CD, and be able to generally scale and improve how we work with data so that we have all the rigor that software engineering can bring and the agility that can come with that.
Absolutely.
Brilliant.
Looking forward.
Well, thanks so much, Steph and Owain, for jumping on and presenting on today's topic, particularly as well as some challenging issues at the start around the internet bandwidth. But thank you both for that, and brilliant to have you. And Steph, we'll see you in a couple of weeks as well again for the next session.
Great.
Thank you guys very much.
Thank you, everyone.
Okay, so there's just a couple more things to cover in today's session. That's particularly around the community side of LunchBytes. So you can go ahead and find your local community at aka.ms/UK community. And if you'd like a call out or to get involved, please get in touch at lunchbytes@microsoft.com. There's a few events going on across February, across the UK at Microsoft, particularly, for example, there's an Ignite redelivery on the 29th of February, and there's an AI workshop as well done in the London Paddington office on the 27th of February. So if you'd like to get involved, please visit the website. And so if you're already working with us, brilliant, please reach out to your account team about other training options. But you can also look out for some of our other episodes at aka.ms/lunchbytes. You can go ahead and see Owain's and Steph's previous content that they've delivered on the live stream. So that's everything for today's episode. We'll be back in 2 weeks' time talking about data ops. So brilliant to have everyone joining. And if there are any questions as well, please do reach out to the LunchBytes team afterwards. You can contact us on LinkedIn or reach out via email. Thanks very much, everyone, and we'll see you soon.